Okay, back here with managed quality. Managed quality is all about, are the processes being followed? And so we encourage a quality audit. This is an independent team that's going to come up and inform us of that, right? It's going to conduct failures, and it's going to see if we're doing continuous process improvement. So we have our inputs and our outputs. Our outputs are going to be, since we're looking for these summaries, these quality audits and things, a quality report, right? What should we take corrective action on? And it's also going to look at our test and evaluation documents, of course, and then make change requests as necessary. So in managed quality, though, there are a bunch of tools. Too many to go over. You'll have to refer to the PMBOK guide, but really they're summarized here, so it's easy reading. We could do data gathering. I could use checklists to gather data. I could do decision making, which it could be in the form of multi-criteria decision making or some prioritization matrix. I want to think about how I represent the data, either in a flow chart for quality, or a scatter diagram, or a histogram, or a cause and effect diagram. We'll look at those here in a minute. I will encourage audits, right? This structured, independent, external team, right? It's going to reduce my cost of quality. And they should be random. They could be scheduled too. I like surprises, right? It's an audit. I want to know that we're doing the right thing. We could do data analysis. What are the alternatives to our current approach or process, and root cause analysis? And I could do design for X, or DFX, right? So if I have these variables, I analyze a variable during the product design. I call that variable X, whatever I want X to be. Reliability, deployment, assembly, safety, etc. Whatever X is, I design for X. And I could do problem solving. I love problem solving, that they define the problem and then they talk about the root cause, identify solutions, choose the best one, implement it, and test it, verify it, right? That's a good process to memorize. Great test question. Here's a quick note about quality audits. I've largely talked about it, but it's structured independent team to ensure we're complying with organizational policies and following the processes that we set up. They are meant to also help us identify best practices and create benchmarks, right, and reduce the cost of quality. Now, those managed quality tools, these are your data representation tools. So flowcharting came up. A typical flowchart is here on the right, where you end up with a decision point in the diamond and yes or no decisions, right? Traditional flowchart. Also note that for the exam, SIPOC is a type of flowcharting, and that stands for suppliers, inputs, processes, outputs, and customers. SIPOC, a type of flowcharting. Continuing with the managed quality data representation tools, I could do a scatter diagram. So basically it takes two variables, one on the vertical y-axis, one on the horizontal x-axis, and plots them. And if I get this sort of plot, it's called a strong positive correlation. This would be a strong negative correlation. This would be a possible positive correlation, and on the XY axis this would be a possible negative. It's not real tight, it's not real precise, so we're not sure. And of course this up here is no correlation at all. Continuing with data representation tools, I have a histogram. Histogram is just a bar chart. It's very useful for showing peaks, right, and to help isolate common causes. But a Pareto diagram is that same bar chart, but they're reordered in the order of frequency, right? And then I can estimate up to 100%. Normally the Pareto rule applies here. So if I take 20% of my issues or my categories will solve about 80% of my problems. That's the 80-20 rule applied in the Pareto diagram. There's also a cause and effect diagram as a tool, and it's also known as a fishbone diagram. You can kind of see the head of the fish here where the problem is stated, and then you ask why. So sometimes it's called the 5 whys diagram or the why diagram. It's been called the fishbone diagram and the Ishikawa diagram. And it's a root cause analysis tool. In fact, if the test mentions root cause, it likely is referring to the cause and effect diagram, or what we know as the fishbone diagram. So here's your problem. You say, well, why did that happen? And somebody says, well, processes, and somebody else says people, and measures and materials, equipment. Okay, then why in equipment? You begin to list the reasons. You ask why, till you can't ask it anymore, and you determine the root cause that way. We can also do affinity diagram, which is going to group like items, and a matrix diagram, which we've talked about before. Also, an important part of being a project manager, and especially here is the issues log, right? It's used to manage. I never walk around without having the issues log in my hand, okay? And if I hear of an issue, even at the water cooler, just talking to somebody, I'm going to write it down, track it down, assign an owner to it, and then follow up with that person later. One, they know they're heard and they were listened to. 2, they're impressed at the feedback. And 3, I now have a forever partner in my project, an advocate. So manage quality. Now we transition to control quality. And control quality is product oriented. Manage quality is process oriented, right? Hence the audit and the benchmarks. This is control quality is about the product, controlling the product. And so we could use statistical control, right? And so these are some definitions to know: prevention versus inspection, attribute sampling, which is pass-fail, versus variable sampling, where the results are rated on a continuous scale, and tolerances versus control limits. You can read those for yourself. The term mutual exclusivity should be known, and that's when 2 events can't occur in a single trial. I can't flip a coin and have both heads and tails, right? Probability means likelihood or chance or the opportunity that something will occur. Life occurs in some sort of normal, natural variation. So there's a natural distribution, right? And when we say the normal distribution, we're trying to understand the common probability density. Where is most of our data going to fall? And then the term statistical independence, that one event does not affect the probability that another event will happen. When I flip a coin, the fact that one flip was heads doesn't mean the next flip will be tails. The next flip is statistically independent. So in control quality, we have these inputs. Notice one of the inputs is approved change request. That was also an input to your process 4.3, direct and manage project work. So approved changes are going there into execution, and it's coming here into control to make sure that that change was implemented. And of course, an input is the deliverable itself. I need to verify the deliverable in control quality, so it becomes an input. I have lots of tools to include data gathering, data analysis, inspection, and representation. One of the data gathering tools is a check sheet, also known as a tally sheet, where I just add things up that are happening and see what is happening the most. Inspection was also a tool used, if you noticed, in validate scope. So the customer will use inspection. So I would expect, this is my team, this is the project manager's team doing control quality, that I would do inspection also and testing. Okay? Statistical sampling is a way to do testing, right? There are times you don't want to test the entire population. One, there are too many. That's one reason. Another is the output is sensitive, and in tampering with it, you have a bigger chance of breaking it, right? If it's very sensitive. So there are lots of good reasons to do statistical sampling. Now, quality control outputs include, of course, every control process outputs includes work performance information, change requests, plan updates, and document updates. Every single one of them. What's new here are the measurements and validated deliverables. So I have this deliverables as an input, but now as an output, my team has looked at the deliverables and validated, and I'm right here, and it's ready now to go on to validate scope with the customer. Okay. You also should be aware of control charts. Here's a good one-slide summary of a control chart. This is the symbol called sigma that you'll often see. And a normal control chart, if they don't tell you what the sigma is, use plus or minus 3 sigma. The mean is just the average. That's the dotted line across the middle. That's the average. Specification limits are set by the customer. And if something is above or below the upper or lower control limits, it's generally considered out of control. The only exception to that would be the rule of 7, which you can read about. Now here's that chart in big picture. So all of these data points are up and down, this natural variation. This is in control. When the data point ends up here, it's now out of control. It's above the upper control limit. And this is called an acceptable range of variation. I'm okay with that data there. The only exception to that is this rule of 7. I'm within the upper and lower control limit, but these data points, these 7 dots in a row, aren't varying. There's no natural variation. That's also a problem, and we want to assign a cause code to that. It's the only time within the upper and lower control limits that we would assign a cause code. Here are some common tenets, terms, and precepts for quality. Just be sure you pause and review those. They're fairly self-explanatory. Some final thoughts are just in time. Just in time is a supply side version of quality where ideally stock is reduced to 0. That's really not possible. Like washers, right? I want to sell a washer, replace a washer. But really I got to have one in the backup or close, right? But it's close, and that's what we're trying to get to. ISO 9000 is a standard given to us, the International Standards Organization. ISO 9000 are your quality standards. And then this is a slide just about the sigma and what it means. And you do need to memorize these 4 for the exam. 6 sigma is 99% quality, 99.99 actually. 3 sigma means that 99.7% of your data points will fall within your standard. Or you could, another way to think of it is you could expect 2,700 errors or issues or rejects per every million items produced. 2 sigma is 95% are within the mean, and 1 sigma means 68% of your data is within the mean. Here's a great one-slide summary of the 3 processes. Again, like all the other summary slides, review it for yourself. But here's what's happening within plan quality management, within managed quality, and within control quality. And these are the major outputs in plan quality, control quality, managed quality, and control quality. Well, that just wraps it up. It's a good summary. Listen to this, put it to a recording, jog to it, watch it, flip through your notes, make your own notes, and do the readings. Okay, thanks. See you in class. Happy to answer questions.